So vertical and horizontal transformations. So I want you to look at two words here. We got a transformation and we have a translation. They are very similar words, but they mean very different things. So those are the two that kind of get intertwined and mixed up a little bit. So let's start with translation, because this is the easiest one. A translation is when you take a point on a graph and you apply a rule to it. You're going to move all the points on this graph, they're going to move 5 units left. Okay? So it's that rule, and this one, a translation, is either up, down, or left, right. So that's the nice one. It's really easy to do. You're going to say, hey, you're going to move 5 units left and 2 units right. You guys have done this in quadratics when your vertex is not at 0, 0. You've done the translation. So a translation and I'm just going to call it a relation for right now. Do you guys remember the difference between a relation and a function? Okay. That's grade 10. That was a long time ago. You've moved past that now. Remember that relation can be any connection between the values, but a function is really specific. You can't have a repeated y value, right? So you can't have a coordinate that's 1, 1, and then have another coordinate that's 3, 1 in a function. Does that make sense? Like the y values can't repeat on themselves? We'll get to it. It'll come back to you. So we're going to say apply to a relation, or graph of a function. This pen's really thin. Rule applied to a relation or a graph of a function. So essentially a translation is moving it around that coordinate plane, but it's not changing the shape of it. So the graph itself looks exactly the same, but its location on the coordinate plane isn't the same as the original. So you can move left or right. And this is an and or, because you can do multiple transformations at once. And that's what's going to be the difficult part. Okay, so translation is the easiest, because it's about moving the translation. Okay, so now we're going to go up to, this is specific. Translation is a move. And this is a move, or it's a stretch. Now, the opposite to stretching is compression. Stretch, compression, contract. So a transformation is any change to the relation sorry, it should say and or and. And or a stretch. So it can change its location, and it can be talking about changing its shape. So a transformation, sorry, you can't see that. A transformation encompasses all of it. Transformation can refer to a move, it can refer to a stretch, it can refer to a compression, it can refer to a reflection. So transformation is kind of like the big umbrella term, but a translation is something really specific. It's going to move it only. And they're both T words, and they both start with trans, and one's a formation and one's a alation. Okay. So mapping. Mapping is super fun. I'm going to do this with my grade 10 intros. All you're doing with mapping is you're relating one set of data to another set of data in the relation. Like your XY charts, right? Your X is related to your Y, and there's a specific relation between them. Mapping notation is just a way to express that. And I really like mapping notation because it's the straightforward math. So the way we do mapping notation is super easy. So let's say I want to translate. So I want to move my graph 2 units up. All I want to do. I want to move it 2 units up. What am I going to do? Is that going to affect my X values or my Y values? Y, because Y is about the range, right? And we're going up. So what am I going to do to all my values of Y? Add 2. If I was at 10 and I want to move that 2 units up, where am I? I'm now at 12, right? So it's straightforward math, and this is the mapping notation. So I want to move 2 units up, like that's the words that go with it. So the mapping notation would be, I start with my coordinates x, y. I draw a nice fancy arrow. It's not really fancy, but it's an arrow. Did I do anything to my x values if I want to go 2 units up? No. So I just repeat the x. And what did I do to my y values? I added 2, so I'm going to say my y values plus 2. So the mapping rule is really nice because it's nice and straightforward. You can tell what we want to do here. Make sense? This is where I start. This is my rule. And we know that it's going to result in a translation because I'm moving my shape up. Okay, those are the definitions that you need to know. Transformation, translations, that'll mess with you for a little bit. Okay, vertical shift. We just kind of did one. What's a vertical shift? What's vertical? Up and down. So, oh my God. You getting a phone call? You good? You need to take that? Oh, you found your phone right there on your desk safely. Okay, good. So vertical is up, down. Vertical is up, down, and we're shifting. So literally, it's a move. We're moving it up or down. Easy peasy. So we're moving it up or down. That's what we're going to do with a vertical shift. Now, we've done a mapping rule for a vertical shift already. Nice and straight and easy peasy. So if we want to, let's do a vertical one for a move down. Let's do a mapping notation for a move down. I want everybody to write one on their page. I'm not going to do it, you're going to do it. So you're going to do a mapping rule for a single vertical move down. By how many units is up to you? Look at your friends' stuff, see if they're doing it right. Okay, did you write out the words first so you remember in your notes what it looks like? So you're going to do 3 units down? Okay. So we moved three units down, so we're going to start with our original points. And we don't know what they are. We're making a generic statement about them. We're going to draw our arrow because that indicates that this is our rule and we're moving forward to it. We don't do anything to the x's, but our y's, we're going to subtract 3 from them. Nice and easy, right? Okay, horizontal shift. What are you doing? We're going left and right, right? We're moving left and right, and it's going to affect the domain or the x values. Maybe we should put that with the vertical. I'm just going to put in brackets here that it affects the range / y values. And again, ladies and gentlemen, these are your notes, so you've got to make them make sense to yourself. And if this doesn't make sense to you or you don't need that in there, don't do it. I will never check your notes. Okay, so this is going to affect our domain and the x values. All right, so I want you all to create a horizontal shift. And you can do, let's do a shift to the left. So we're going left. So if I go 4 units left, we're going to be doing this to our x's now. So if I was at 0, 0, and I move 4 units left, where am I now? -4. So we're going to have x minus 4, and nothing's happening to the y's, right? Okay, I'm going to switch colors of pens because I'm going to blow your mind now. Okay, and this is where things get confusing. The mapping rule is so nice because it gives you the straight map. So let's talk about function notation. You guys remember function notation? F of x, g of x, that sort of stuff. Everybody's like, no, don't remember it, don't want to. It feels like it's going to get complicated, don't want to do it. Okay, so let's go back to grade 10 for a second. Do you guys remember, like, the y value in the f of x is the same thing? Like, I could go f of x equals x plus 2. Okay, function notation, you guys with me here? Okay, so what if I did this? Do you guys know what to do there? Okay, so what did I replace here? The x. So what gets replaced on this side? The x. So we would have 2 plus 2. So f of 2 is equal to 4. What does that mean as a coordinate on a graph? Y equals 4. What's x? 2. You guys remember that? Vaguely? Sort of? You've just learned grade 10 all over again. What if I said f of x equals 6? So what happens here? What is f of x is equal to 6, so what gets replaced in this question? The f of x gets replaced because we made a statement that x is equal to this, so we would have 6 equals x plus 2. What is x? Hopefully x is 4. What's the coordinate that goes with that? 4 and 6. Okay, everybody breaking out in a small sweat now? Function notation. That's just a little refresher, and you're going to hate function notation with transformations because it gets confusing. So I need you to commit to really having an open mind and being okay with it. All right. Okay, so going back to the vertical shift, what did we do to this? When we did our 3 units down, what did we do? We subtracted 3 from the y, right? So now I'm going to put that in function notation. What letter or letters represents y in function notation? F of x. You need both of them, right? You need the f and you need the brackets and you need the x inside. That's your y. So what we did was we said y, where our new function is going to be whatever our y values were, and we're going to minus 3 from it. Oh, mind blown. Mind blown. Okay. So that one's not too bad because you're just saying, hey, I've subtracted 3, right? Yep. No. No. It's just a habit I've gotten into, and it looks fancy, and really, that's what I'm here for. Okay, so now, ladies and gentlemen, do you guys remember, I'm going back to my scrap piece of paper, do you guys remember vertex form? Do you guys remember that? Okay, so now I'm going to test your knowledge. I'm going to test your knowledge again, and I want you guys to tell me where the vertex is in that quadratic. Red's really bad to see, I'm sorry. Kirsty's all over this, yes. So my vertex is going to be at -2, +3. Do you guys remember this? That the x never tells you the straight story, right? Like y does, like it's a +3, it's a +3. Y is all on the up and up, everything's good there. But it's because the equation has the subtract in it. So the only way for it to be a +2 is really like saying x minus a -2. Right? That's essentially what it's saying there. So you need to know that you're going to do the opposite of what's happening. So you've done all of this. You've done all of this in your quadratics. So now we're going to put it in function notation here. You ready? So what's happening? What are we affecting this time? We're touching the x. So x is never going to give us the straight story. Right? So if we're needing to go left and we're subtracting 4, this one's going to be y equals f. And now I'm going to put in the brackets. So these are the ones that were being affected. So it's going to be x plus 4. So in function notation, things become a little bit more complicated. And that's why the mapping rule is really nice. I encourage people to go back to the mapping rule because it's a straightforward map. Like, it's not going to lie to you. It's not, already Danika's like, done, I'm out, she's switching rules. So your mapping rule tells you what math you have to do, whether you have to add or subtract. You can pull it out of function notation. You just got to remember when you're dealing with a horizontal shift, you're going to do the opposite of what it's telling you to do. Okay? You guys remember this. You did already do this in grade 11. We just didn't talk about it in this way. Okay, we can only sketch the graph once we know the parent function, and sometimes it's called the original function. You just need to know what graph you're dealing with. All right. Okay, I'm just writing this up here. So I want you guys just to look at that for a second. It might not pop off the page at you because they both have f of x in them. And this is trying to get it like sort of straightforward in our head. So the parent function, we would say it is f of x. Now sometimes you get the equation, which would be x squared. You guys all know how to graph that, right? Sure. It's your basic parabola from grade 11 that you lived, slept, eat, breathed. Pardon? That's 0, 0. The vertex is at 0, 0. You guys are all living your best lives graphing that. Here, let me throw up. I'm going to pop to Desmos. If you've never used Desmos before, it is an online graphing calculator. It's got a bunch of other tools. Yeah, you might be able to. Sorry. Oh, geez Louise. There we go. Okay. Oh, gonna get everybody sick. So that's your basic function. In this case, we know the equation, so it's really easy for us to graph because we know how to do a table of values. We know how to graph it using all the tools we had in grade 11. Sometimes though, I'm just gonna give you the graph. And the graph will be something you've never ever seen before. It might be like a sharp straight line, hit a vertex point, come back up and flatten out. Like it might not follow a traditional graphing equation. So sometimes you're given the equation and sometimes you're given just the picture. So let me just pop back into this so we can see your notes. So this one obviously is the equation. We know how to graph that. We have all the information given right here to graph this, okay? This one, it's function notation. It doesn't tell us anything about the graph. If I just gave you here, this is f of x, and I don't give you the picture with it, there's nothing you can do with it. This one, you can make your picture. Does that make sense to everybody? Like you can make your own graph from it? So let's pop down to this. This is, talk to me about the translation that's happening. Talk to me about the translation. Oh, and I gave it away because I said translation instead of transformation. But we'll go with translation. What's the translation that's happening here? Up 3. Perfect. It is, if we go to function notation, it might be a little easier to see. We're taking the y values and we're adding 3 to them. So this is up 3. Oh, I said I wasn't going to use red because it's hard to see. I don't listen to myself very well. Okay. So let's talk about C. What are we doing here? Okay. Remember function notation. You guys just did, I'm saying you just did this, but it was grade 11. What are we attaching it to? You're definitely right. We're going left and right. It's a horizontal. But what does the horizontal, the x never tells us the straight story? So we're going right 3. Okay, so that's going to be the difficulty there. Yeah. Yeah. But only for the x. X is the only one that messes with you. Y is always going to tell you the straight story.
So when we go down, it's all going to be x squared, but we're just going to use
Okay, geez Louise. Which one's the original? I'm all panicky. I don't know where the original is. Let's call this one the original. Y1, Y2, Y3. Okay, guys. Okay, Y1, so the original, it says blue function, but it's the one with the vertex at 0, 0. I really need to get some more highlighters up here. I feel like I've... Okay. That's my original graph. Okay, so we're going to do it 3 ways for each one. We're going to say it in words, we're going to say it in mapping, and we're going to say it in function notation. So we're going to do that 3 times. We're going to do it for 3 different graphs. So you guys need to label your graphs accordingly. Y1, that highlighted graph that I just showed there, that's your parent function. So everything is translated from your parent function. We would have completely different answers if we all picked a different parent function. Okay. Deep breath, everybody. So let's go to Y2. Let's go to Y2. So in words, what happened with Y2? Up 3. Look at you guys. Nice. Good job. Okay, now we're going to do the easy one. We're going to do a mapping. I'll give you the front part of it because it's always the same. Yeah, but we need to put that X in there to indicate that nothing happens with that. Oh, you did. Okay, good. Sorry. I was worried too. Function notation. No one wants to do this one. FYI, ladies and gentlemen, it's done above you. F of X plus 3. Because those Y values we're adding 3 to. All right, I'm going to do Y4 first. Y4. Does that mess with you if I do that? Probably. But I appreciate your flexibility. Okay, in words, what's happening with Y4? 4 to the left. Okay, let's map that. Okay, now remember mapping is it's the math. It's not going to tell any stories. It's just straightforward the math. X minus 4. And you all included a Y in there? Perfect. Okay. Okay, but remember that it's going to happen inside the brackets. F, yeah. So F X plus 4. Not terrible, right? So we're going to, but it does get a little bit confusing. So you just got to know, look at, is there an equal sign in there? What's happening with my F of X? Those sort of things. Okay. I'm trying to find a different color. I'm going to go pink this time. Okay, now we're going to do Y3. Everybody see why I left Y3 to the end? Because what's happening in words? So 4 units down. And we went 2 to the right. 2 units right. Okay, so now we're doing something to both the X and Y, which we haven't really done before, but we're good. We can handle that. So we're going to have XY transforms into X plus 2, Y minus 4. See, mapping rule is so nice and easy because it's just the math you actually have to do. So if you had a table of values, you would take all your X values and add 2 to them, and you take all those same Y values and you would minus 4 from them. Straightforward, and you'd graph that new table of values. Easy peasy. So now we're going to do function notation. Okay, so what's happening to the X? So we're going to take away 2. X minus 2. And then what are we going to be doing? Minus 4. We're going to do stretches too on this, right? So we're going to do, like, this is just the moving today. We're just going to move left and right, up, down. And then we're going to actually, like, change the shape of the graph. We're going to stretch it. But you've already done that with quadratics. You've already done it in grade 11. Okay. Here we go. Okay, so ladies and gentlemen, let's point out a few quick things before you dive into this. This right here is the equation of the graph. Okay? That's the equation of the graph. This is function notation. Okay? So it's not putting these changes into the equation. It's just saying, hey, move your graph up by 2, right? So we would move up 2 units on this one. What would we be doing on this one? Right 1 unit. So this stuff is function notation. It doesn't tell you the math to do in that equation. It just tells you what it wants you to do with the picture of the graph. Does that make sense? Like function notation is more about the picture, and the equation is how we're going to draw the original picture. Okay? All right. Do you guys remember how to graph quadratics? No. Okay, when in doubt, let's do a table of values. 100 bonus magical marks if you know where the vertex is and you're not sure, Steve. Or Hein.
1 and 3.
Or Nandi. Sorry, I'm cutting all of you guys out because you just finished. Okay. I will tell you that the 1 is incorrect. But I know where you're getting that from. Okay, let's yes, let's back it up. Which way does my graph open? Down. That negative tells me my graph is opening down. What does it tell me about the width? What does it tell me about the width of the graph? It's normal. If it's 1, it's normal. It's not wide, it's not narrow, it's just regular. The negative tells me it's open. This is in vertex form. What's with the x? Is there anything in the brackets with the x? Are there any brackets? No. So what's with the x? Nothing. How do we represent that in math? 0. So the x coordinate of our vertex is 0. What's the y coordinate? 3. Okay, so if you know where the vertex is, you can do a table of values better. So my parent graph here, I always throw the vertex in the middle. And then I'm going to pick points to the left and to the right. So to the left of 0, -1, -2. To the right, 1, 2. You can never go wrong with a table of values. I think I want to stress that more and more and more in this class. We're going to be doing so much graphing. There's going to be quick ways to do it. But if you lose those quick ways, always go back to your fundamentals of a table of values. Okay. I'm going to jump to my scrap paper just for a second because I want to show you this. So if we're solving for f of -1, so that's going to be -1 squared plus 3. So notice how I wrote that. So this answer is always going to be negative. What's -1 squared? 1, but it's got a negative outside. So that negative outside the x kind of lives outside the x. It's like saying there's a -1 out there. And so my answer would be 2, right? Everybody agree with me? So if I go back to my table of values, this would have a y value of 2. Okay, so do that with -2. Let's see if you can do it in your head. Did I mention that I'm going to take your calculator away? Okay, so as I tell that to you on day 2, I love you all, and I'm very proud of you as mathematicians, but we're going to try to remove our calculator more and more from our math. Most of the math we're going to do is not going to be calculator, like crunching numbers. We're going to be doing more leaving things as radicals and stuff like that. So your calculator is going to go away. Okay, but maybe not today. It's not going to go away today. What do you guys know about a parabola? What do you know about a parabola? It's symmetrical. That's what makes it beautiful. So if you trust your math, if this is one away to the left, then one away to the right should result in the exact same y value. If you trust your math. If you don't trust your math, it's like the second hour on the final exam and you're not 100% sure, you're exhausted, I can't believe I made you do all this math. It might be good just to pump it into the equation to double check. All right, I'm grabbing my pen and I'm going to do some increments on here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -1, -2. Ladies and gentlemen, I talked about this with my grade 11s. Do you have to put increments? Yes, always yes, you have to put increments. But do you have to put a mark on every increment? And the answer is no, just as long as I can see it, that I know what your scale is. But I really suck at visual things, so it really helps me to always write it out. And I've been doing this for a really long time, and that's something I haven't improved upon. So I'm just saying to you guys that if it's a helpful tool, keep it. If it's not, don't. Okay, so 0, 3. My first point. That's exciting, everybody. Isn't that exciting? My next point is at -1, and I'm at 2. And I might as well, while I'm over here, 1 and 2. And then at 2, I'm at -1. And at +2, I'm at -1. Oh. Just ignore that one for a second. I went down too far, see? So we're going to connect the dots with a smooth curve. I'm going to have arrows continuing on. And I'm going to label this f of x, because I'm going to be putting more graphs on the same coordinate plane, so each graph has to be labeled. What else should I do for this graph? I should definitely label 2 points, but I'm not going to do that until the end, okay? Just because I put them on there now and then they get lost. All right, so let's look at, so we graph the parent function. The parent function is f of x. We've done A. Good job, everybody. B is f of x plus 2. So if I were to create a new table of values, what am what's the math behind it? Am I doing anything to the x's? Just adding 2 to all the y's. So what happens with my x's for this table of values? They stay the same. Because the math on the function notation says, hey, just affect the y's. So we're going to add 2 to every y. So 2 plus -1 is 1. 2 plus 2 is 4. 5, 4, and 1. That's exciting. So we're going to graph this graph. So now I'm at 0, 5, 1 and 4, -1 and 4. I'm going to try not to screw up my graph this time. 2, and I'm all the way down at 1. And at -2, I'm at 1. Did the shape of my graph change? No, it did not. Did it move on the grid? Yes, it did. It moved 2 units up. And so I'm going to label this one f of x plus 2. I don't know which graph is better. Okay, last one. It is f x minus 1. So when I do my table of values, I go back to the original function. I'm not doing off the transformed one. It doesn't say anything about adding 2 out here. I go back to the original. So what math is this telling me to do? Add 1 to the x's, right? So that's that mapping rule coming back to us. So what about my y's? Am I doing anything to my y's with this one? No. So my y's are all going to stay the same. But for all of my x's, I'm going to add 1. So that's going to be at -1, 0, 1, 2, and 3. So now I'm going to take those points and I'm going to graph them. Now, some people are really good with visualizing this. Once they get that first graph down, they actually don't need to do other tables of values. They can just do it right on that graph. If you are that visual person, I'm super impressed. I'm super proud of you. You're going to go far in this world, but you're going to leave me behind because I can't do that. I need my table of values. But if you're that person, please feel free to do it. So again, the shape of the graph didn't change. We didn't anticipate any shift here. So if you look at your vertex, it hasn't gone up or down, but we did expect it to move 1 to the right. So all the points just shifted 1 unit to the right. And we did that mathematically by adding 1. But we had to extract that information from the function notation. Everybody good with that? Okay, easy peasy, right? All right.